Today we're going to talk about physical and chemical changes. As you take notes, I want you to think about how you can make these notes your own, use your own style, your own voice, your own words based on the things that I talked to you about. All right, let's get started. So physical and chemical changes is a huge concept in chemistry, and it will form the basis of a lot of what we do here in this class. And so let's talk about the differences between the two. So let's talk about physical changes first. Now, a physical change is a change that does not alter the identity of the substance. And oftentimes, a physical change can be reversible. Now, there can be some exceptions to that. We'll talk about that in a minute. But here's some evidence or some processes that are physical changes and not chemical. So let's talk about each one. A change in state is an example of a physical change. That means if we go from a solid to a liquid or a gas or back to a solid, we're not changing what it is, what the substance is. We're just changing the way that it looks. For example, if we had ice, like in the picture on the left, that ice can turn from a solid, it can melt into a liquid, that liquid can evaporate into a gas. Deposition is what it's called if we go from a gas to a solid, so that can happen as well if it gets really cold again. We can also go in the opposite directions too, right? A gas can turn into a liquid, that's called condensation. A liquid can turn into a solid, that's called freezing. And a solid can turn directly into a gas, that is called sublimation. All right, another example of a physical change would be the separation of a mixture. Imagine that I had a mixture of sand and iron filings, kind of like the lab activity that we just finished up. The iron is magnetic and the sand isn't. So if I added a magnet to the mixture, I can take the iron out and leave the sand. I didn't change what the sand and iron were, I just put them into two piles, right? Another example of a physical change is a physical deformation. I'm drawing a piece of paper. Imagine that I tore the piece of paper in half. That's an example of a physical change. I didn't change what the paper is. Now, I mentioned earlier that physical changes are reversible. Sometimes they're not. For example, if I tore this piece of paper in half, I can't put it back together again, right? So there are some exceptions to the rules. Oftentimes, here's another exception, dissolving can be considered a physical change, especially if we did it, dissolved sugar and water together. If I had some sugar water, I could physically change and get the sugar back by evaporating the water out. I'm not changing what the sugar or water was, I'm just changing the state of the water and getting the sugar back into a solid form instead of being dissolved in the aqueous solution. All right, so we talked about physical changes. Let's talk about chemical changes. Chemical changes are changes that occur when one substance is transformed into another substance. Unlike physical changes, a chemical change oftentimes is irreversible. That means that you can't put it back together again, right? You can't make it go backwards, the reaction. So whenever we have a chemical change, oftentimes it's accompanied with some evidence of that chemical change. And one piece of evidence of a chemical change is a change in temperature. I have a little thermometer here, so we can either go up or low. The temperature can go up or down. Now, you might be thinking to yourself, what if I just heated up a glass of water? Is that the same thing? No. The change in temperature occurs because of the reaction, right? It doesn't happen because you're heating it up from outside of the system. The change in temperature occurs within the system, and it can either become hotter or colder depending on the substances that you mix. Another example, or evidence rather, of a chemical change is a change in color. Imagine that we had a penny or something made out of copper and it reacted with some chemicals around and it turned green. That's an example of a change in color. Imagine if you had, there's my nose, imagine if you put two chemicals together and you noticed a smell that wasn't there before. Odor is an evidence of a chemical change. a precipitate. So imagine that I had a beaker and I added another chemical to that beaker and a solid formed on the bottom of the beaker. This is called a precipitate. If a precipitate forms at the bottom of the beaker, if a solid forms at the bottom of the beaker that wasn't there before, we've got a chemical change. We'll do a lab like this later where we will make some chalk. Production of a gas is also evidence of a chemical change. Here are my little logs. They're on fire, and I'm producing carbon dioxide and water into the atmosphere. Whenever I make a gas, think chemical change. One of the things that's not on this list is production of light. Right? Think about it. The burning logs also produce light. They also produce heat. Right? There's a change in the color of the logs when they're finished. All of this is evidence that a chemical change occurred. If I went too fast, you can go back and rewatch the video. Other than that, you can ask me some questions, and I hope your page of notes looks pretty good. Talk to you soon.